For today, I can simplify exponential expressions with fractional exponents. Read together, 1, 2, 3. I can simplify exponential expressions with fractional exponents. So I said to get ahead, you needed to fill up your Frere model. But today we're going to start with an essential question, and we'll answer it at the end. It says, what happens to an exponential expression? We already know what they are, right? When that has a fractional exponent instead of an integer exponent. Think about it. What happens to an exponential expression that has a fractional exponent instead of an integer exponent? We've already been doing some stuff with it, right? So we'll answer that at the end. But for right now, let me just recap what we've seen so far. We saw the Frere model, and we know that exponential expressions are what? Numerical and variable expressions raised to a power greater than 1. And you wrote your examples, non-examples, and the most important thing to remember, expressions only and exponents greater than 1. Who got that by yourself without looking at your notes? Very good. Yeah, please be proactive and be ahead. Steps. We don't need the steps, but just to revisit, yesterday we wrote, if the exponential expression has a fractional exponent, we rewrite it as a radical and factor the number completely. Identify the index of the radical to find the root, raised to a power outside the parentheses, and simplify. Remember that from yesterday? Yes, Mr. Q. All right, good. So we did something like I revisited prime numbers, and I said prime numbers are numbers that have factors 1 and itself, right? And anything else is a composite. And then from there, I took you guys to elementary. Okay, kids, we're going to do a factor tree. Remember that? So we did factor trees, so we know how to do that. And then from there, I introduced the fractional exponents that become radicals. Are we there? It looks something like that. We did some practice, this, and this. And then we left off here. Is that correct? The last example I covered was with this. So copy this one on your paper, b to the 2/3. And I'm going to elaborate on two different methods, and then we'll move on to the next thing. So just copy b to the 2/3. And underneath that, I want you to write 64 to the 2/3. Now, there's two methods as to how to rewrite this expression. So pens down, eyes up here really quick. 64 to the 2/3, yesterday I showed you that this can be rewritten like this. 64 to the 1/3 times 2. Is that correct? Because 2 times 1/3 becomes 2/3 power of 64. Are we there? If you don't see it, here it goes. 1/3 times 2 is the same as 1/3 times 2 over 1, which is 2/3. Are we there? So, with that said, I said this we already know how to do. This becomes cube root of 64. This reminds me, since it's multiplying, reminds me to open a parenthesis and raise to a power of 2. Therefore, what number times itself 3 times gives me 64? Let's see, 1 times 1 times 1. No. 2 times 2 times 2. No. 3 times 3 times 3. No. 4 times 4 times 4. Yes, 4 times 4 is 16 times 4 is 64. Therefore, it's 4. Bring down the parenthesis, and the power. So what is 4 squared? 16. Copy that, please. That's the first method that I showed you, and I'm going to show you why I asked you guys to use this method, because the other method, even though it is the same, you get the same answer, it requires a little bit more work. Okay? Copy that. Now, let me show you the second method. I'm going to go this way. This could be rewritten a second way. According to the commutative property of multiplication, we can write this instead of 1/3 times 2. Couldn't it be 2 times 1/3? And it gives us the same 2/3. Is that correct? So watch. So this could be rewritten as 64 to the second times 1/3. Do you agree with that? Yeah, because this is the same as that. However, we already know, let's see. Look at this. What is 64 squared? That means we need to multiply 64 times 64. What is 4 times 4? 16. We got 1. 24 plus 1, 25. That's 24. We got 2. 36 plus 2, that's 38. This is 6, 9, 10, 4. So this becomes 4,096. And what does this indicate? To open a parenthesis. And what is the power? 1/3. So now, what happens when we have a fractional exponent? It becomes a radical, right? So this is cube root of 4096. So, let's see. So far, which one looks a little bit easier to work? This one or this one? This one, right? That's why this is the first one I showed you yesterday. I didn't want to get you confused with this for the home play. So, if I was to factor this one, since it's a huge number, what did I ask you to do? When in doubt, factor out. So at that point, I would start doing my factor tree, right? Divide by 2, divide by 3, and all of a sudden I'm going to get like a huge tree over here like this, right? At the end, guess what I'm going to get as a cube root? 16. So, which method do you think I'm going to ask you to use? The one on the right. Everybody with me? Because it's a lot simpler to manipulate like that. So with that said, copy this, please. Let's do some practice on your paper. Copy A. We're going to do A together. Don't copy B. We're going to do that till the end. Example 2, it says A is 81 and 5/4. Let me zoom in. So let's do this one together. First things first. We need to rewrite the exponent. Is that correct? So instead of being 5/4, it has to be 1/4 times 5. So then I write 81 to the 1/4 times 5. With red, I'm going to circle the first part because I already know what to do with this. This becomes a radical, doesn't it? 4th root of 81. What does the multiplication remind me of? To open a parenthesis and bring down the power of 5. So let's do the inside of the paren. What number times itself 4 times gives us 81? 3. So we're done with the inside. Bring down the parenthesis and the 5. So what does this mean? This means 3 times 3 times 3 times 3 times 3. What is 3 times 3? 9 times 9 times 3, 243. How are we doing? Good? Example Q. Right next to that, I want you to do this next one by yourself. Let's do 8 to the 6/3. Actually, let's make it 5/3, sorry. 5/3. Copy that and see if you can do that by yourself. Go. Okay, help me rewrite this, please. Boss, what do I write? Times 5. Hands if you did that. Okay, pass it to someone. Chris, what do I do from there? Cube root of 8. Parentheses to the. Pass it to someone. Sergio, cube root of 8 is? Cube root of 8 is 2. One number times itself 3 times gives us 8. 2. Very good. And pass it to someone. Patrick, what is 2 to the 5th? What is it? 32. Hands if you got that. Okay? Do you see it now a little bit smoother, right? All right. Let's do some more practice. I'm going to skip that one for right now. Copy these two, please. See if you can do those two by yourself. And I'm going to push you the screen right now for Nearpod, and you can send me your answers once you're done. Make sure you lock your screen. I mean your toolbar. Copy that and do them by yourself. Go. So here we go. So let me go over C really quick. So for C, we rewrite this. This becomes 16 1/4 times 3. Is that correct? This becomes 4th root of 16 and all that to the 3rd power. 4th root of 16 is what number times itself 4 times? Oh, give me 16, that's 2. And all that to the 3rd power. 2 times 2 times 2 is 8. Are we there? Now this is where some of you get confused. This one, you did a lot of work. Some of you got a little bit confused. That's fine. But from now on, I want you to know that anytime you see 1 as a base, doesn't matter the exponent, the answer is always 1. So you can save some work. Yeah. Bam. 1 and 3 over 0. What happens there? Let me take you back to the beginning of the year. Remember the definition for quotients? Remember that? What did it say? That n cannot be what? 0. So therefore this is undefined. Right? But the other way around, yes. So any other exponent, doesn't matter if it's 1 million or if it's 0, the answer will always be 1. Everybody got it? All right. So with that said, look at that one, copy that, and I'll send that on Nearpod. Here it goes. It looks like the answer was 81. Is that correct? Yes. So, for those of you that are still having a little bit of difficulty with those, let me go back. It's going to clear your screen. Remember that I am staying for tutoring, so please stay, because I'm going to go over the home plate during tutoring. So, just to go back to the original question, remember at the beginning I said, what happens to an exponential expression, or what's the difference of having a fractional exponent? What happens when it has a fractional exponent? It becomes a what? When an exponential expression has a fractional exponent, it becomes a what? A radical, right? All right, so for home plate tonight, pages 32 to 34, answer the questions that have blanks. All right, have a good one, guys. Enjoy your home play. I'll see you guys tomorrow. Bye. And I'll upload the video at the end of the session today. Bye.